Very good morning, students. We'll start our lecture 11 on irrigation requirement of the crop. In lecture 10, we discussed on crop water requirement. In that, we had a parameter of irrigation requirement. In today's class, we'll deal about the irrigation requirement of a crop. What is irrigation requirement? It refers to the amount of water that is required to bring the soil condition to the field capacity to meet the crop water requirement. So we call it as irrigation requirement. It is the amount of water applied field by supplementing the effective rainfall, soil water contribution, groundwater contribution to meet the crop water requirement. And the formula goes as if irrigation requirement is equal to water requirement minus effective rainfall, the soil contribution and the groundwater contribution. If you see here, the next related to this irrigation requirement is we have two terms, net irrigation requirement and gross irrigation requirement. What is net irrigation requirement? It is that amount of water that is required to bring the soil to the field capacity condition. So that we call it as net irrigation requirement. Here with the formula we can calculate the net irrigation requirement. It is a summation of I tends to 1 where moisture content in the field capacity is subtracted by moisture content before irrigation, that is multiplied by the soil bulk density with that of a depth of the soil divided by 100, we will get the net irrigation requirement. It is a multiplication of soil bulk density by depth of the soil layer in a centimeter with the difference in the moisture content at a field capacity and that of a before irrigation. A good example has been represented here. If you see the moisture content at an individual depth with a different moisture content in the field capacity and that of before irrigation. What is field capacity? Condition after 2 to 3 days of irrigation where most of the water is drained out and water is present in the micropore. So this is the moisture content. It is a higher as compared to before irrigation. So what we have to do? We have to take the summation of individual observations. If you see the moisture content at 25 centimeter depth, it is 25.01. At 25 to 50 centimeter depth, it is 26.01. Similarly, at 75 to 100 centimeter depth, it is 11.55. If you take the soil profile net irrigation requirement of, if you say a depth of 100 centimeter, it is total of 75.048 mm. Most important questions with respect to the net irrigation requirement for the crop. The next is gross irrigation requirement. The two terms which I have told you, the net irrigation and the gross irrigation. Gross irrigation requirement refers to the total quantity of water including the efficiency is gross irrigation requirement. So it can be calculated by net irrigation requirement divided by the irrigation application efficiency multiplied by 100 gives you the gross irrigation requirement, because when you are applying irrigation water, individual system has different application efficiency. Drip has 90% application efficiency, flood irrigation has just 50% application efficiency. So that determines the total quantity of water as compared to that of net irrigation requirement. So gross irrigation requirement is equal to net irrigation requirement divided by application efficiency. A good example from last problem, if you see the net irrigation requirement of a irrigation system, it is 84.5 and the application efficiency is just 65. So how much quantity of extra water you have to apply? If it is 130 mm, if you subtract with net irrigation requirement, you will get around 40-50 mm of extra water you have to apply now to bring the soil to the field capacity condition. The next is irrigation interval. At what interval you are applying the irrigation water? It refers to the number of days between the two successive irrigation during the period without precipitation for a given period of a crop and a field. It depends on what factor? Depends on the crop eating and also the available water holding capacity of the soil in the root zone, and sandy soil requires generally the more frequent irrigation as compared to that of fine textured soil. See, as we were discussing that soil texture structure determines the water holding capacity of the soil. So irrigation interval is in what frequency of from one irrigation you are applying to that of next irrigation, we call it as irrigation interval. And sandy soil, the water holding capacity is low, you need to apply more irrigation, and the clay soil water holding capacity is high, you have to apply the lesser irrigation, a lesser interval. The next, the fourth definition is irrigation period. What is the irrigation period? The number of days that can be allowed for applying one irrigation. If you are applying today's one irrigation, how much days you are applying that one irrigation determines the irrigation period to a given design area during period of highest consumptive use of a season, and is mathematically expressed as irrigation period is equal to net irrigation requirement divided by peak period of consumptive use. Peak period of consumptive use. What is consumptive use? The water required to meet the evapotranspiration and metabolic need of the plant. So by using the net irrigation requirement divided by peak period of a consumptive use, you can calculate the irrigation period in a day. For an example, the irrigation period net irrigation requirement of a crop is 65.55 mm, whereas peak period of consumptive use is 7.2 mm. See, if we divide that net irrigation requirement divided by peak period of consumptive use, during the peak period, how much water is absorbed by the plant? You get around 9 days of irrigation period is important for applying one irrigation. The next, after understanding these important definitions, will come across with few other definitions in irrigation agronomy. What is that? They are core watering. Core means first. The first watering is called as core watering. The next is core depth. The depth of first water irrigation or depth applied in first watering, we call it as core depth, and a core period. It is the part of a base period during which core watering is done, and the base period. What is base period? The period of days by which water is applied to a crop from first irrigation to the last irrigation, we call it as base period. Then we have duty, delta, and base period are the three important terms to calculate the individual fractions. They are related with each other. What is base period? The number of days which water is applied to a crop from sowing to harvest. How many days you are applied? It's called as base period. The duration of a crop. The next is the duty of a water. Duty means how much area that can be irrigated from a irrigation source. We call it as duty. It is area irrigated per cubic of discharge running for a base period. We call it as duty. So duty is D is equal to area to be irrigated divided by quantity of water applied. Area to be irrigated to the quantity of water applied forms the duty of a water. I am applying around 10,000 cubic of water. How much area it is covered? We call it as duty. Then what is delta? It is the depth of water. How much depth of water is covered from a duty? The depth of water during a crop during its duration, we call it as delta. It is volume of irrigation water to the area irrigated. Volume of irrigation water to the area irrigated. And the relation can be duty of the total depth of water delta is equal to 8.64 multiplied by base period divided by duty gives you the total depth of water. Net irrigation area irrigated only once in a year. This term, not net irrigation requirement. Net irrigation area is area irrigated only once in a year. Whereas gross irrigation area is area that is irrigated more than once in a year. Net irrigated area plus area is more than once in a year. It forms the gross irrigated area. So, after understanding the crop water requirement in last lecture 10 and irrigation requirement in this class, we'll now understand how much is the minimum amount of water required for the crop growth and development. If you see here, this is a wonderful chart. In most competitive exam, they ask this. The rice required the highest and called around 1200 mm of water as compared to that of a duration. Then wheat required 450 to 650 mm of water. Sorghum required 450 to 650 mm of water. Maize required 500 to 800 mm of water. Sugarcane required 1500 to 2500. However, the duration of this crop is 1 year, whereas rice it is around 5 months. So, the water requirement of rice is 1200 mm. Sugarcane it is around 2500 mm. This wheat and sorghum is same, around 450 to 650 mm. Then sugar beet it is 550 to 750 mm. Groundnut 500 to 700 mm. Cotton 700 to 1300 mm. 700 to 1300 mm. The soybean required around 450 700 mm. Tobacco required 400 to 600 mm. Beans required 300 to 500 mm. See here, From this data, you can see here the pulses required lesser water as compared to that of cereals. Around beans around 300 to 500 mm. Then pea around 350 to 500 mm. The tomato required around 600 to 800 mm tomato. Then potato also required around similar amount, around 500 to 700 mm of water. Then onion required 350 to 550 mm of water. Chili required around 400 to 600 mm of water. Cabbage required 380 to 500 mm of water. See, after the perennial, the banana required around 2200 to mm of water. Citrus, these are the perennial crops. Yearly it required around 900 to 1200 mm of water per tree. Then grape required around 700 to 1200 mm of water. Mango required 1000 to 1200 mm of water. Turmeric also required a high amount of water, around 1200 to 1400 mm of water. Yes, we'll stop today's lecture here. We'll start the next lecture with factor affecting the crop water requirement. Thank you.